12.2. Alright, so what we're going to do today, you might remember from like 7th grade, but still, some of you might remember it. My younger people might remember it. I don't remember learning this in school, but it's a very, very applicable for stats. So frequency distribution and statistical graphs. So frequency distribution, a piece of data is a single response to an experiment. So like if I asked the class what's your favorite color and 7 of you said green, that's a piece of data. A frequency distribution is a listing of observed values and the corresponding frequency of occurrence of each value. So the number of children per family is recorded for 64 families surveyed. Construct a frequency distribution of the following data. So it's finding how many children are they have in a family. So number of children. So number of children, that's actually known as our observed value. And then after our observed values, it's the number of families. And that's called our frequency. So we have number of children, because that's what we asked. Then we got the answer of how many of those families did we ask. So number of children, that's all of our numbers here. We have 0 through 9. Start off smaller. Start off too big. Yeah, my bad. Oh well. Alright, so now we count how many zeros do we have. We have 8 zeros. That means 8 families that they asked had 0 children. Now we count how many ones they have. There's 11 ones. So 11 families had 1 child. We count how many 2s we have. There are 18 2s. So that means 18 families had 2 children. We count how many 3s we have. We have 11 3s, so that means 11 families had 3 children. We count how many 4s we have. So we have 6 families have 4 children. We count how many 5s we have. We have 4 5s. So 4 families have 5 children. We count how many 6s we have. We have 2 6s. So 2 families have 6 children. There's 1 family with 7 children, 2 families with 8 children, and 1 family with 9 children. And just, make sure that the total is 64, so you counted right or you didn't miss any. And it is. If you added all this up, we do get 64. That's all a frequency distribution is. Alright, rules for data grouped by classes. The classes should be the same width. I'll talk about width in a second. The classes should not overlap. Each piece of data should belong to only one class, often suggested that there are 5 to 12 classes. Your left side is your lower class, your right side is your upper class. The midpoint of the class is found by adding the lower and upper class limits and dividing the sum by 2. We're going to talk about all that, don't worry. Alright, example 2. A frequency distribution of family income. The following set of data represents the family income in thousands of dollars, round to the nearest hundred, of 15 randomly selected families. So the first thing that we need to do is rearrange the data. We need to have it in numerical order, but we're going to set it up the same way. So you see how it's a 3 by 5? So when we rearrange it, we want it to be a 3 by 5. So let's rearrange the data. We go from smallest to biggest. So 31.8, 40.3, my bad, we have to go down. We go down. I do that every semester. So 31.8, keep it going. 35.5, and then 39.8. So you see how we have our first column? Now we have to move on to our next column. Now we go on to 40.3, 40.9, 44.6. Next column, 44.7, 45.8, 46.5. Next column, 48.8, 50.7, 52.4, 53.7, 56.3, and 65.2. Alright, so we rearranged our data and we made it have the same shape. Now we can go ahead and figure out a whole bunch of stuff here. So if we want to construct a frequency distribution with the first class of 31.5 to 37.6. So a class is a range. So see here how we only had 0. So we could make this 0 to 2. So how many people answered 0 to 2 children? And then we would add all these up. So that means we can find our class width. So our class width is how much does each group hold. So a class is like a group. So to find our class width, we subtract. So we do 37.6. My bad, 37.7. You always round to the next one. You always go to the next point or the next number. And we subtract that by 31.5. And we get our class of 6.2. So that means every group is going to be separated by 6.2. So we can actually find the next class. So the next class is going to be 37.6 plus 6.2, and we get 43.8. And then to find the next class after that, we just keep adding 6.2. So let's actually make our frequency distribution. We have income, and income is based on how many thousands of dollars you make. And then we have number of families. So our first class width, it told us our first class is 31.5 to 37.6. Our next class we found was, next number up, 37.7 to 43.8. Then we add another 6.2, so 43.8 plus 6.2 is 50. So we have 43.9, because that's the next one up. So 43.8 plus 2.6, we get 50.0. So our next one up is 50.1, and 50 plus 6.2 is 56.2. I'm adding by 6.2 because of that one right there. Our next number up is 56.3. So 56.3 plus 6.2 is 62.4. I have to keep going until I can fit in the last number. So I have to do it one more time. So the next number up is 62.5. And 62.4 plus 6.2 is 68.6. So now we list how many times each of those families, how many numbers fall in between that range. So 31.5 to 37.6, that's 2 of them right here. That's 2 of them. So 2 families answered that much money. Our next one, we have 37.7 to 43.8, and we have 3 of them. Our next is 43.9 to 50. So we have all the way any number between 43.9 and 50. And that is 5 of them. Now we move on to our next class, our next group, 50.1 to 56.2. That's 3 of them. Next, we have our next class of 56.3 and 62.4, which is only 1 of them. And then our last class is 65. Oh, my bad, just 1. That's a 1. Let me change that color, that's horrible. 1. Now we have our frequency distribution. So we can find a lot of information here. I didn't ask you to find this, but let's find this. The modal. It's like model, but with an A, the modal. Modal means most, or also known as the mode. But because we're working with classes, we call it the modal. So which one has the most? That class right there. That's the modal. So it's the most class, which is 43.9 to 50.0. So the most of they surveyed, most people make about 43, almost 44,000 to 50,000 a year. We can find the class mark. So the class mark is it's kind of like the midway point of the classes, kind of. So what we do is we take the first class, which is 31.5, the last class of that value, so of the next class of 37.7, and you divide by 2. And so you add these up, divide by 2, and you get 34.55. That's called the class mark. If you wanted to find the midpoint of the classes, so if you wanted to find midpoint, change color here. You would do you would add the lower and upper class limits and divide by 2. So you would add 31.5 to 68.6. and divide by 2. Let's actually do that. I don't have that written out. So 31.5 plus 68.6, you get 100.1, divide by 2, and we get the midpoint of 50.05. Alright, histograms. You know what a histogram is? It's actually it's a bar chart. A histogram is just a bar chart. So a histogram is a graph with observed values on its horizontal scale and frequencies on its vertical scale. Because histograms and other bar graphs are easy to interpret visually, they are used in a great deal in newspapers and magazines and pretty much everywhere. Constructing a histogram. A bar is constructed above each observed value or class when classes are used, indicating the frequency of that value or classes. The horizontal scale need not start at 0, so you don't need to start at 0. And the calibrations of the horizontal and vertical scale do not have to be the same. The vertical scale must start at 0 to accommodate large frequencies of the vertical scale and may be necessary to break the scale. Alright, basically, I'll sum all that up for you. So, we want to treat this as if it were a T-chart. So a T-chart, these are our X's, these are our Y's. So your vertical, as they say, your vertical scale, that's just your Y values. So our vertical scale, you always want to start at 0 for your vertical scale. So 0, and then our highest number is 18, so I'm going to go 0 to 20. Just a nice round number, you know? And then our horizontal scale, which are our Y values, X values. I was looking at the Y. So for the X's, it's 0 to 9. So that's the only X's I'm going to have, 0 to 9. So for our Y values, those represent number of families. to paint to write sideways on here. So we have number of families. I can't write it all because I can't touch the screen with my palm, so it's weird to write. And on the bottom, we have the number of children. So number of children, we're going 0 to 9. Made it too big. Oh, so we have 0 through 9. And then our number of families, we have 0 through 20. Now, I'm not going to write 0 through 20. We're going to go by 5s to write it down. But we will put 20 tick marks. So that's 5, 10, 15, and we'll just say 20 is on top. Yeah, there's 20. Make it fit. All right, now we do these all. We look at our number of children, we look at our number of families, and we put it on our graph. So, oh, we're missing 0. We're missing 0 there. Forgot that. All right. So for our first one, we had 0 families, or 0 children. 8 people said they had 0 children. I'll get tongue-tied on that one. So 8, so 5, 6, 7, 8. 8 people had 0 children. So it's kind of small. And then 2 people, or 11 families had 1 children. So 11 had 1 child. Okay. Keep going. 18 families said they had 2 children. or 11 families had 3 children. Six families had 4 children. Four families had 5 children. Gonna have to start repeating colors here. 2 families had 6 children. One family had 7 children. Two families had 8 children. And then last, we had 9 children, 1 family. There we go. There is our histogram, our bar chart. All right, frequency polygon. Frequency polygons are line graphs with scales the same as those of a histogram. So basically, it's a histogram, but except you use dots and then you connect the dots. I'm not going to explicitly show you how to do it. I'm just going to switch screens real quick so you can see. It's pretty straightforward. I'll walk you through it though. Alright, so our x's and y's don't change. We still have number of children and number of families, and you still see it's still 0 through 9 and 0 through 20. And so we just plot the points. So 8 families had 0 children, so 0 children, 8 families right there. 11 families had 1 child, so 1 child, 11. 18 families had 2 children, so 18. And then after you plot all the points, you just connect the dots as best as you can. Alright, stem and leaf is next. So stem and leaf display is a tool that organizes and groups the data while allowing us to see the actual values that make up the data. I like to just jump right in to it and not have it be too complicated with directions. So it's called a stem and leaf. So we have stem and leaf. So what we want to do is look at the first digit of every number. So the first digit of every number, we have 2 through 7. Now, everything with the 2, we're going to write the second digit of that. So see how we have 29, so 29. That reads 29. Then we have 27, so 2, 7, 27. And then we have 28. So 2, 8, 28. So let's move on to our 3s. We have 31, so 3, 1, that's 31. We have 39, so 3, 9, 39. Next we have 32, so 3, 2, 32. It does not have to be in order, which is great for this. You don't have to put it in any order, you just write it as is. Next we move on to our 4s. So we have 43, so 4, 3, that's 43. Then we have 47, so 4, 7. Next we have 44, so 4, 4. And then we have 45, so 4, 5. And then we have another 44, so 4, 4. You do repeat values here. Alright, 50s. We have 56, so 5, 6. 56, let me rewrite that. Then we have 59, so 5, 9. 58, so 5, 8. 50, so 5, 0. And that's it for our 50s. Let's move on to our 60s. So for 60, we have 60, so 6, 0. 62, so 6, 2. And 68, so 6, 8. Now last but not least, we move on to our 7s. So we have 71, so 7, 1. And 72, so 7, 2. And that's a stem and leaf display. Circle graphs, also known as pie charts, are often used to compare parts of one or more components of the whole to the whole. So circus performers, 800 people attended a Ringling Brothers and Barnum and Bailey circus, were asked to indicate their favorite performance. The circle graph shows the percentage of respondents that answered tigers, elephants, acrobats, jugglers, and other. Determine the number of respondents for each category. So we want to find out each category and how many people actually liked that category. All right, so we have tigers. Not going to even jump on that one. Elephants. Then we had acrobats. Jugglers. And then we have other. I'm going to do other in black, but it actually is this one right here. Can't really see the yellow. Okay, so for tigers, it's 38%. So 38% is 0.38. So that means 38% or 0.38 of the total. So 800 liked tigers. So we're going to multiply by 800. So 0.38 times 800, and we get 304 people liked tigers. Elephants were 26%. Which is 0.26. So 0.26 of 800 people liked elephants, meaning that's 208 people. Multiplied. Acrobats, 17%, which is 0.17. So 0.17 of 800 people liked acrobats, so 0.17 times 800, we get 136 people. Jugglers were 14%, so 0.14 of 800 people like the jugglers, and that's 112 people. And then other, we have 5%, which is 0.05, so 0.05 of 800 people, and that is 40 people liked something other. You should always add up your values to make sure you didn't mess up anywhere, and it is 800. Cool. So how many people is actually the answer? So 304 people like tigers, 208 people like elephants, and so on.